Okay, let's just dive right in. If you're working with data today, I mean, especially anything touching AI workloads, you know the feeling, right? It's sort of like being handed this incredibly complex city map built over ages, no real plan.
Yeah, a bit chaotic.
Exactly. You've got data and object stores over here, metadata somewhere else entirely, different engines trying to process things.
For sure.
Maybe you're battling with formats like Apache Iceberg just to, connect the dots.
It's definitely fragmented, a real labyrinth, like the source says.
And the sheer amount of data, it's just exploding. Multimodal AI is really pushing that hard.
Absolutely.
So right into this complex situation steps VAST Data, pretty new company, right? Founded about 6 years ago.
That's right. Relatively young in this space.
But they've managed something kind of remarkable already. They apparently hit $2 billion in cumulative software revenue faster than, well, any data infrastructure company ever.
Which is, yeah, incredibly fast growth that definitely
Yeah.
makes you pay attention.
It does. And it raises the big question, the one that's really central to the source material we're looking at today. It's an article from DataPro.News titled Vast Data, Revolutionary AIOS or Silicon Valley Hyperbole.
Catchy title.
It is. And the core question it's wrestling with is basically, is vast data a real breakthrough, something that actually changes the game? Or are they, just the latest vendor making big splashy promises?
A familiar story in tech sometimes.
So our mission for this deep dive is pretty straightforward. We're going to unpack this article, pull out the key insights, and really try to help you understand what VAST claims, what the evidence looks like, and critically, what it means in the real world.
Sounds good. Let's get into it.
Okay.
So the article starts by setting the scene really well, describing that problem we just talked about, the traditional fragmented data stack.
Right. Separate bits for everything.
Exactly. Storage, indexing, processing, managing the data structure. It's all separate systems. And each layer adds complexity, potential slowdowns, more overhead to manage. It's often just not built for these heavy-duty modern workloads like AI training or real-time stuff.
And VAST comes along and says, hey, we can fix this. We can simplify.
That's the core idea, yeah. Unification. Bring storage, compute, data management, put it all onto one platform.
How do they actually do that?
Well, the foundation is what they call their DACE architecture. It stands for disaggregated, shared everything.
Okay, DACE.
And the big vision, as the article lays it out, is that this architecture isn't just like fast storage. They're aiming for it to be the base of what they call an AI operating system.
An AIOS. That sounds vicious.
It really is. And there's a quote in the article from VST co-founder Jeff Denworth that kind of sums up this ambition perfectly. He says, "There's a huge data problem. We sit in the center of that whole pipeline. Our system is both a distributed enterprise data warehouse and a distributed unstructured data store, so every single step of the pipeline can be solved with a unified high-performance and extremely affordable enterprise platform."
Wow. Okay, so solving every step. One platform to rule them all, basically.
That's the pitch. Very bold.
It's a huge promise. And I assume they back that up with some performance numbers. Yeah. The article must mention benchmarks.
Oh, absolutely. They've published comparisons against, more traditional setups or things built on Apache Iceberg, and the numbers they're putting out are, well, they're pretty eye-catching.
Let's hear them.
Okay, so they claim warehousing queries run 25% faster, but using 30% less CPU.
Faster and more efficient. Okay.
Then, for those needle-in-a-haystack type searches, they're saying 20 times faster, using only a tenth of the CPU.
20 times faster. That's significant.
But maybe the most standout claim is around updates and deletions. They're claiming 60 times faster compared to typical object-based solutions.
60 times. Wait, okay.
Huh.
Updates and deletions?
Yeah.
That's always been a major headache for data lakes, right? Especially with object storage.
Exactly. That's historically been a real weakness. If they can actually deliver that kind of speed up for updates and deletes.
That solves a massive pain point.
Yeah, it really does. But, and this is important, the article is careful here. Right after listing these impressive numbers, it adds a strong note of caution. It says these figures demand scrutiny and that engineers should approach them with healthy skepticism until independent verification becomes available.
Right. Vendor benchmarks are always, vendor benchmarks. You have to test it yourself.
Precisely. They're a starting point, not the gospel truth.
Makes sense. So beyond just the speed claims, you mentioned VST focuses specifically on AI. The article highlights that.
Yes, very much so. This AI first angle seems to be a core part of their identity and marketing. They're not just saying we're fast. They're saying we're built for AI.
How so? What specific AI features does the article mention?
Well, one big one is vector search. Their VAST database apparently claims to be the first vector database that can handle, get this, trillion vector scale with constant time search.
To trillion vectors. Okay, that's serious scale. Why is that important?
Think about RAG systems retrieval augmented generation. That's where you feed your own data into large language models.
Right, becoming super common.
Yeah. Or any kind of similarity search. Doing that efficiently at massive scale usually needs complex, separate vector databases. ViadST is suggesting their platform can handle it natively, potentially simplifying the whole architecture quite a bit.
Interesting. Integrating that capability. What else?
They also talk about real-time processing with something called the VAST data engine. It offers serverless triggers and functions. The idea is you could react to data changes instantly, maybe even bypassing traditional ETL pipelines for some use cases.
So, cutting down on data latency for certain workflows.
Potentially, yes. Though the article doesn't dive deep into how revolutionary that really is compared to existing streaming tech, the intent for real-time reaction is clear. And critically, given the AI focus, they've optimized for GPUs. Things like asynchronous checkpointing, quality of service controls, features designed specifically to keep expensive GPUs fed with data and running efficiently during training.
That makes a lot of sense. GPU utilization is key for AI economics.
Exactly. It's a direct response to how costly and compute-intensive training large models can be.
So, the picture emerging is not just fast storage, but a platform designed to actively help with the whole AI lifecycle. Is there evidence this is actually working in the real world? Does the source mention customers?
It does. It points to customer testimonials suggesting, genuine value delivery. And it cites a really high net promoter score, an NPS of 84.
84? Wow, that's exceptionally good for an enterprise tech, isn't it?
It really is. The article notes that puts them up there with some of the most trusted brands globally. That signals strong customer satisfaction.
Any specific examples?
Yeah, the big one mentioned is Pixar Animation Studios. They apparently migrated petabytes of rendered assets onto VST.
Petabytes. Yeah.
And the key reason given was specifically to enable future AI applications. Not just for storage, but for what they plan to do next with AI.
That's a strong signal. Betting on VST for their future AI roadmap.
Definitely shows confidence in demanding, forward-thinking places. Plus, the article mentions impressive growth figures near 5x year-on-year growth in a recent quarter, and partnerships with big names like NVIDIA and the major cloud providers.
Okay, so NVIDIA, cloud providers, that suggests real market traction, not just hype.
Seems so. These partnerships and growth numbers are pretty solid indicators of significant market acceptance.
All right, so compelling vision. Check. Big performance claims with a grain of salt, check. AI features, check. Market validation, check. But this wouldn't be a proper deep dive if we didn't look at the other side. The skepticism, the limitations, the article gets into that too, right?
Absolutely. It balances the picture. While acknowledging the impressive growth, the source brings in some independent analysis that highlights important gaps compared to the big established players. There's a quote from the QB Research, which says that even with their rapid growth, VAST has not yet achieved a Databricks-style lakehouse, a Snowflake-grade cloud database, nor a hyperscaler data platform.
Ah, okay. So that puts it in perspective. They're making waves, but they're not necessarily a full replacement for a Databricks or a Snowflake yet.
Exactly. Not feature for feature across the board. And the article digs into one specific area, their database.
Yeah.
It seems it's primarily built as a really fast index for metadata and vectors, which is great for what it does, but apparently lacks a full ANSI SQL engine. It doesn't have all the mature governance, security, and management tools that people expect from a proper enterprise database.
Okay, that's a critical distinction. If you're relying heavily on SQL for analytics or data management,
It's not a direct swap. It's a different kind of tool, optimized for certain things like vector search, but not a general-purpose SQL database replacement.
got it. What about cost? Is it cheaper, more expensive?
The article describes their pricing as kind of middle of the road, not the cheapest, not the most expensive. However, it does flag a potential hurdle, the need for an all-flash storage infrastructure. Running VAST requires a substantial capital investment in flash storage.
Ah, so even if the software TCO works out, you need that potentially pricey all-flash hardware underneath.
That seems to be the implication. Compared to hybrid systems or just using cheaper spinning disks, the upfront hardware cost for flash could be a factor for some organizations.
Needs careful calculation then. Okay, beyond cost and the database aspect, what other practical things should people think about if they're considering VAST real-world implementation stuff?
The article raises a few key points for data engineers. First off, migration complexity.
Always a big one.
Always. Even though VAST supports standard protocols, S3 SMB, moving existing pipelines, especially if you have petabytes of data, is never simple. It's inherently risky. The article basically advises that any claims of seamless migration need careful validation in specific environments. You can't just assume it'll be easy.
Yeah, no migration is ever just a click of a button. Been there.
Definitely. Then there's the vendor lock-in concern.
Ah, the double-edged sword of unified platforms.
Exactly. While having everything integrated simplifies things, it could also mean you become heavily dependent on Viacity. The article points out that even though they support open standards, committing deeply might make it hard to switch out components or, move away from Viacity later on.
So you're trading some flexibility for that potential performance and simplicity.
That's the trade-off you need to weigh up. Performance
Yeah.
benefits versus long-term flexibility and avoiding lock-in.
Makes sense. Anything else on the practical side?
One more point, operational maturity. VAST is still, relatively speaking, a young platform compared to the giants NetApp, Dell, Snowflake, the cloud providers. The article suggests they might not have the same depth of operational experience, the huge ecosystem of third-party tools, or maybe the super mature support processes built over decades.
And their fast growth, ironically, could strain their support.
That's a potential risk the article mentions, yeah. Rapid growth is great, but scaling support effectively alongside it is always a challenge for younger companies.
These are all really crucial practical points for anyone who actually has to run these systems day in, day out.
Stepping back again, the article also places VAST in the bigger picture, right? We talked about data growth at the start.
Yeah, it revisits those numbers. That jump from, 41 zettabytes in 2020 to a projected 200 by 2025.
Just staggering growth. It really is. And so much of it is unstructured, complex data-censored data, simulations, high-res media, and of course, all the stuff generated by multimodal AI. Traditional systems just weren't designed for this kind of scale, complexity, or the way AI needs to access data.
Which naturally creates this huge market opportunity. The article throws out a number for the next generation storage market, $150 billion by 2032.
Yep. That kind of potential attracts a lot of investment, a lot of innovation, and inevitably a lot of competing claims about who has the best solution.
So in that crowded, rapidly growing market, where does the article suggest VST actually fits best? What are the sweet spots?
It lists several scenarios where VST's particular strengths, that real-time performance on big data sets, the AI features, seem to align well. Things like financial services needing fast access to huge amounts of transaction data for, say, real-time risk checks.
Okay, low latency is key there.
Definitely. Media and entertainment, we saw the Pixar example handling massive files, accelerating AI in rendering or content analysis. Scientific computing, especially HPC clusters, feeding data-hungry GPUs and CPUs without bottlenecks.
Right, HPC needs that throughput.
And also areas like manufacturing or energy, dealing with industrial IoT data, running analytics on operational data streams.
So specific industries and use cases where their architecture really shines, despite the limitations we discussed.
It seems so. It suggests there are concrete problems where their approach offers real advantages.
Okay, so we've covered a lot of ground from this DataPro.News article. The big vision, the performance claims and the caveats, the AI focus, the market buzz, but also the database limitations, the lock-in concerns, the maturity questions. Bringing it all home, what's the final verdict from the source? Cautious optimism. Something else.
That's exactly the phrase they use. Verdict. Cautious optimism.
Okay, so optimistic, but with reservations.
Pretty much. The article concludes that the compelling vision, the rapid growth, those strong customer testimonials, and the clear focus on solving real AI challenges, all that suggests there's substance behind marketing rhetoric.
So not just hyperbole. There's something real there.
Yes, but the optimism is definitely tempered. It stresses that VAS feels more like an evolution rather than a revolution. It helps with certain problems, but also introduces, new dependencies and limitations.
Right, like the lack of that full SQL engine or the vendor independence worries we talked about.
Exactly. Those are highlighted again as valid reasons for caution, balancing out the excitement around the growth and the benchmarks. Ultimately, the article's main takeaway seems to be that choosing VAST isn't a simple yes-no. Success depends on matching VAST's specific strengths to organizational requirements.
It's not a magic bullet for everyone. You have to see if your specific needs align with what they do well.
Precisely. It's positioned as an intriguing option, something promising enough to investigate, but definitely requiring careful due diligence before you jump in.
So they've definitely made an impact, stirred things up, but maybe not completely rewritten the rules for everyone just yet.
That seems to be the conclusion, yeah.
Okay, we started this by asking if VST data is a genuine breakthrough or just, typical Silicon Valley hype. And based on our deep dive into this DataPro.News piece, the answer seems to be, well, it's complicated, it's nuanced.
Usually is.
Yeah. They clearly have significant innovation. They've got real traction, especially where AI is involved. But there are definite limitations, real-world trade-offs, and it requires that careful evaluation against your specific situation.
Which actually leads to a pretty interesting thought for you listening. When you think about these trade-offs, the rapid innovation and potentially game-changing features of a newer player like VST versus the known quantity, the maturity, the broader ecosystem of established players like Snowflake, Databricks, or the hyperscalers, how do you approach that evaluation?
Yeah, especially when it involves potentially big investments, maybe some lock-in risk, and performance claims that aren't fully independently verified yet. How much is that promise of future AI optimization and simplification worth compared to the stability, maybe the known limitations, of the systems you already have?
It's a tough balancing act. How do you weigh potential versus proven, innovation versus maturity?
Definitely something to think about as you navigate this constantly shifting data landscape. Thanks for joining us for this deep dive.